And then you guys are free to take any remaining time to work on the chapter review. Oh, and we should talk about the test format here at some point too, right? Does that sound good to you guys? So no new content today. We'll start with questions though, if anybody has anything from the homeworks or anything else. Be happy to address them. Jacob.
Yeah.
Okay.
Can we do 59?
I'd be happy to. '59 says find sine theta and tan theta if cosine theta is equal to 2/3 and cotangent theta is negative. Okay. So I'm going to start by first establishing what quadrant I'm going to draw my triangle in. So cotangent is negative. Well, I remember that cotangent is y over x. So for y over x to be negative, I need one of the two quadrants to be negative. So that means I'm either in the fourth quadrant or in the second quadrant. Are you okay with that? I should write it over here. Okay. I also know that cosine is positive. I remember that cosine is x over r. So cosine would be positive wherever the x is positive. So that means it would be in one of these two quadrants. The quadrant with both pieces are true is the fourth quadrant. So that's where I'm going to draw my triangle. Is that okay, Jacob?
Yeah.
Okay. So I'm going to draw my triangle. I always draw my triangle back to the x-axis. So this is, we shouldn't probably call this theta, right? Technically speaking, theta is this, but I'll call this angle phi. Draw it out here so everybody can see the symbol I'm using. And since cosine is equal to 2/3, I know that this side is 2 and the hypotenuse is 3. Okay with that? I'm going to find this other side using the Pythagorean theorem. So I know 2 squared plus y squared is equal to 3 squared. So y is going to equal the square root of 5. But because we're in the fourth quadrant, this is the y coordinate. So I know this is really negative square root of 5. And now I have everything I need. So I know tangent is, this is y over x. This is x over r, or x over y, excuse me. But like, it didn't really matter. It didn't change anything, right, for what we were doing. So this is negative square root 5 over 2. And sine is y over r. So that is negative square root 5 over 3. Okay with that? Okay. So again, this is one where drawing the picture I think makes an enormous difference. I don't think it's very reasonable to consistently do these problems without drawing a little XY axis and putting your triangle in there and drawing some pictures. And I think it makes life much, much easier to see what it is that you're doing. Highly recommend doing that. Who's next? Dan. 49, you say? Okay. says, if an angle falls within the given interval, determine whether sine, cosine, and tangent will be positive or negative. Okay. So the interval that we have is pi comma 3 pi over 2. So my first goal would be to draw up a picture. So this is an angle that's somewhere between pi and 3 pi over 2 radians. So if I remember my unit circle, or I just remember that each quadrant is pi over 2 radians apart, my angle that lies somewhere in there would be in this third quadrant. Okay with that, Dan? So that's going to be between pi and 3 pi over 2 radians. So in that third quadrant, the x-coordinate is negative and the y-coordinate's negative. Maybe we'll just write it this way. And the r is always positive. R is always positive regardless of where you're at. It's a length, it's a radius. So anything with just one y or just one r is going to be negative, and anything with y and x in there is going to be positive. So sine is y over r, which is negative over positive, which means that that's negative. Oops. Cosine is x over r, which is negative over positive, which is negative. And tangent is y over x, which is negative over negative, which is positive. So sine and cosine are negative, but tangent is positive. Does that feel okay there? So again, I drew a picture for this. I think, again, helps enormously to have something to kind of look at, to give yourself a frame of reference. There's a lot of different modes of thinking about this going on, and I think it really helps to have a physical diagram to look at to help reason things out. Because as you can see, nothing I did was super involved from a computational standpoint, but it wasn't trivial either, right? I still had to really understand what was going on. And the picture, I think, helps enormously me to kind of see what's going on. Is that okay? Who else has something that they want to talk about? Isabella? Sure. So 52 says find the exact value using reference triangles. And here we have tan of 7 pi over 6. So I'm going to leave this all in radians rather than converting it to degrees. Not that you can't convert it to degrees, and it's perfectly reasonable to do that. I'm going to leave it all in radians because I think it's helpful for you guys to get used to seeing things in radians and not have to convert to degrees every time. So I'm going to kind of talk through how I do that in my head so that you can kind of see what it is that I'm doing while I'm doing that. Is that okay, Isabella? Okay. Because it's an important skill to develop at some point. So 7 pi over 6, I'm going to think about really as 1 pi plus 1 pi over 6. Right? 7/6 is really the mixed number 1 and 1/6. So 7 pi over 6 is really just 1 pi and then 1/6 of a pi. Is everybody okay with that idea? So I'm going to draw this angle now on my xy axis. So 0, pi over 2, pi, and 3 pi over 2. That means that my angle theta is right there. Just a little bit past pi degrees. Or I'm sorry, pi radians. Cool with how I've drawn my picture. Very important that we're able to get that angle in the right quadrant. Now when I draw my reference triangle, what I'm going to do is I'm going to draw back to the x-axis, and I'm going to think about this triangle. So this angle here is just pi over 6. How can I tell that? I know from here to here was pi, so here to here must just be pi over 6 more. Is that okay? We can see that. If you don't understand what I'm doing, please stop me and interrupt and ask and say, no, I don't understand. I'd be happy to say it again, to go slower, look at it a different way, make a different analogy. But it's hard for me to look at your faces and determine like how things are going with the masks on. So if you can verbalize things a little bit for me, that's helpful. And if everything is fine, you can say, yeah, that's fine. Keep going. Sometimes it's unclear to me like where the hang-ups can be on these problems because there's a lot of detail going on, right? Okay. So pi over 6 I know is the same thing as 30 degrees. So what I'm looking at is a 30, 60, 90 triangle. So this side is like, instead of using x's, because I have x's and y's as coordinates, I'm going to use a's. But that's going to be negative a, because it's in the third quadrant. And this is going to be negative a root 3. And this will be 2a. Again, I'm just using a instead of x, because I don't want to use, we have x and y coordinates. We have definitions for sine and cosine that involve x's and y's. I don't want to involve x and y here because I don't want to get confused at. So I just chose a as a letter because I know I don't have anything in my formulas that involve an a yet. So I just used a. So far, so good? Okay. So then I know that tangent is opposite over adjacent. So that's negative a over negative a root 3, which really reduces down to 1 over root 3. And when we rationalize the denominator, that's root 3 over 3. Isabella, is that okay? What's the easier way to do this, though? I go to my unit circle, and I do y over x.
Are we going to have that for yourself, or we're going to memorize?
You're not going to be asked to memorize unit circle at any point this year.
Okay.
Does that sound good?
Mm-hmm. Yeah.
Okay. Now, if I ask you to do this question using reference triangles, I expect to see the picture that I've drawn here, or something similar to that. But if I just ask you to evaluate this, you're free to use
So yeah, it's
the
just
unit
mainly
circle.
just knowing how to do like a 30, 60, 90, and 45, 45.
Exactly, yes.
Okay, that's good.
Agreed. It's not. But it's one of those like,
I thought we were going to have to memorize something.
no. The answer to that is no.
Okay.
That's a good. Hopefully, that's a relief to everybody. You'll notice that on the content library, I put the unit circle and I put the blank version in case you wanted to practice. You know, like drawing all those 30, 60, 90, and 45, 45, 90 triangles. Like, can be helpful exercise if you're trying to get used to doing that skill that you just asked about. I put a blank one in that you can fill out yourself and kind of draw in. If you want. You don't have to do anything with it, though. Okay. Anyone else with homework questions? Very good, then. I'm going to end the recording here because I'm going to stop the projection and then talk about the test a little bit? Is everybody okay with that? But I don't want to pull up the test so I can give you, actually I can do this. I have copies made already. What am I thinking? Don't be so dumb, Mr. Kulik. Sorry, sometimes you just have a dumb day. Okay. So let's see, what should we be able to do? Okay, so you have two questions where you have to convert back and forth between degrees and radians. Will you be given the formula to do that conversion? No, you should have that memorized. I'm trying to write them down, at least some scritchy scratchies of what it is that I'm saying. You have one question using that arc length formula. So remember that has two versions. You have the radian version, and then wait a minute, what was it again? I even forget now. I only just remember the radian version. Is that bad? That might be bad. I should know it. That's what it was. That's what it was. So one question where you have to solve a right triangle. Am I going to expect that you know like sine is opposite over adjacent and all that jazz? Yes, that should be memorized. I don't think that's a problem for most of us. We seem pretty solid on that. Okay, we have one question where I ask you to draw angles of rotation. So like that's like we did this in class where I just asked you to draw like a 760-degree angle or something. Everybody's okay with that idea? Should be able to do that with degrees or radians, positive or negative. All I'm really looking for is that it's in about the right quadrant. So you should be able to find, I have two questions where I ask you to find the exact value using a unit using the unit circle. Will you be given the unit circle? Yes. All right. One question where you have a point on the terminal side of your angle. And then we want you to find the 6 trig ratios. So there you're going to need the x, y, and r definitions for sine, cosine, tangents, cosecant, secant, cotangent. Will you be given those? No. Expectation would be that you have those memorized. And then one question where I ask you to find the exact value. Given two pieces of information, similar to like 59 and 60 from the homework. And that's the test. in a nutshell. And again, if you didn't write all this down, don't worry, because it's in the notes that are on the content library, so you can always go back and look at it. So it'll always be there for you, which is nice, right? Yeah, so we have, what, we have 30 minutes or so left in class. So you notice on the content library, there is a worksheet practicing using the unit circle to find exact values. So this is similar to these last two parts of the homework. And there's a review sheet. Notice that the review sheet also has a key attached to it. That would be part of your homework check for Sunday, is those two assignments. My suggestion to you would be to do them in advance of the test, since it's direct practice for things on the test. And the test is scheduled for Wednesday this week, right?